Yeah, hello and good morning. Please, can you hear me?
Can hear you, sir.
Okay. So, once again, you're welcome back um, to this semester. The course for this semester is calculus for engineers. So, we'll try our best to be able to look at the course content, and then from there, we'll look at what is expected of us. Okay. Um, to start with, I want to thank all of you for what you did for my birthday last week. I appreciate that. I hope this semester will be able to interact um, very well so that you get the best out of what this course is all about. Okay, so we'll look at the course content briefly and then review some of the things that we did in functions. Basically, what is a function? What is the domain of a function? What are the ranges of the function? And also review some of the things we learned in limits. We'll end with some of the worksheets, which obviously will be our way of testing what we have learned. So let's look at the course outline. I must confess that I'm still populating the details on the course outline. So on the LMS. So if you go to the LMS, you see that I have posted a course outline and some of the worksheets. The PowerPoint and the things that we use, I'll be gradually populating them. So on your screen, you should see the course outline. So calculus, basically, predominantly, we'll be looking at application of differentiation and its application and all that. Okay, so this course is course 112, second semester, and it has all the details in the first page. But what are we to look at? So the fundamental principles of differential and integral calculus. Basically, that is the main aim of this course. We looked at a few of differentiation and integration last semester. We want to extend this to several variables and then develop concepts for vector calculus. So we'll be looking at some advanced differentiation techniques, its application, and then some theorems of calculus, integration, improper integrals, multivariable calculus, optimization with constraints, vector differential operators. So these are the course uh, content. These are the details of what the course is all about. So the objectives one is that we want to explain and interpret the various concepts in the differential integral calculus. Also want to apply these differentiation and integration techniques to solve mathematical problems. And three, how to analyze functions using maxima and minima and some mean value theorems. Um, Last semester, we look at how to evaluate indeterminate forms of integrals or indeterminate forms of differentials. We will look more into that again in this in calculus. How to apply partial differential equations. Um, how to use the Lagrange multipliers, and how to compute and interpret gradient and divergence and curl functions. So basically, at the end, we should develop a very good mathematical and problem-solving skills, good for um, a course and good for engineering. Your learning outcomes are one, how to differentiate, two, how to determine maxima and minima functions, and what is Leibniz formula, how do you apply it? Evaluate limits, including indeterminate forms, main value theorem, perform integration evaluate improper integrals, compute partial and total derivatives, solve constraint optimization problems, and then calculate gradient divergence and curl vector fields. So these are the learning outcomes, and these are the course learning outcome as well. The books I recommended. This morning I was trying to see if I can download a few of them. So I was able to get this one, and then Advanced Engineering Maths. Then I think Stroud. So you can go to this website, forshare.com. If you have a Gmail account, the website is forshare.com. With a Gmail account, they will allow you to search for books here. So I came and searched for at least 3 of the books. I haven't searched for the others. So this one, this is K. Stroud. Obviously, these are scanned documents. So you may get the original, but they are scanned. So this case Stroud, Engineering Maths. Then the second one was Advanced Engineering Maths by Rising. And then the third one is Calculus Early Transcendentals. So this site can help you download some of the course outline. So if you are interested in doing that, okay, you can get access to, if not all, some of them. You know the way we assess. I mean, that I give a lot of assignments, which are worksheets that you practice. So those ones, and then the quizzes that you will see on the LMS. Again, I am yet to populate these ones. And then the final exams, okay? And then the grading criteria too is being repeated here. The topics for each week has been designed in the form of a model form. So every unit and what we are supposed to look at. So unit 1, we are actually supposed to look at review functions and limits, logarithm functions, parametric and differentiation, all the way up to some application to differentiation. Then we come to unit 2, application to derivative. Unit 3, limits and intermediates. Limit 4, integration. Limit 5, functions and several variables. And then limit 6, calculus and optimization. So it's been designed like that. So gradually, we are going to look at all these, hopefully, before you end your course. Any questions? Any comments? If not, then we go to a review. Okay, so if you don't have a question, we are looking at just a review of definition of a function and its components. This we've done last semester, but we want to take into cognizance how to identify domain and range and codomain of a function, and how to evaluate their range and their ranges and their domains when you are given a problem. So we're going to spend time on that, and then we'll end with some exercises. I'm still dividing the PowerPoint, so the PowerPoint I have is not in the format which I want, but we will manage with that for the meantime. Okay, so these are the outline for today, functions and their domain, but we'll delve more into their domain and their range. So all we need to know are the rules of a function. Last semester, I think the PowerPoint defined a function as picking every element in a domain and mapping it to a unique element in a codomain. So we are going with the same rule. So the rule that assigns each element in set A. So my set A is the elements in the blue domain, and then my set B is the elements in the codomain. That is my range. So all we are saying is that you pick each element. So the element 1, the element 3, the element -4, and then you map them to an element in the set of B. So that will be a function. If this rule is satisfied, then whatever mapping you have is a function. So 1 maps to -1, 3 maps to -6, -4 maps to 1. Okay. Now, if it is written in the form of an equation, then we should be familiar with the notation. If we say that y is equal to 3x plus 2, if we claim that this is a function, then the values of x will be our domain, and the values of y will be our range. Okay, values of x will be our domain, and values of y will be our range. And then we write f of x in place of y. So this will read f of x is equal to 3x squared plus 2. Now, note, it is not f times x. Oh, okay. So this is the terminology. We say f of x. We don't say f times x. Now, function notation example. So what is f of -2, f of 0, f of b plus 1 in the equation 3x squared plus 2? So what do we do? Now, we are picking the various domain values as -2, the value 0, and the value b plus 1, and want to find the range. So when we substitute -2, we get 3 minus 2 squared plus 2. So here my range is 14. When we substitute the value 0, we get 3 times 0 squared plus 2. Again, we end up getting the range to be 2. But if you substitute the function b plus 1, then we are going to get an equation that involves b. So 3b squared plus 6b plus 5. Okay, so this is an example of evaluating functions when you know the inputs of the domain and then evaluating the range on these inputs. This is another type of a function. So when you ask you to find the domain of a function that is written in the form of a fraction, how do you determine the domain? Okay, so here our function is in the form of a fraction. A fraction is normally called a rational function. If you write a function where you have a numerator and a denominator, then the function is a rational function. So 2x divided by 3x minus 1. Now, for this one, the method is that you must look at the denominator, because you know when you have fractions, we normally do not want the denominator to be 0. So all we need to do is to equate the denominator to 0, or make sure that when you equate the denominator to 0, the value of x should not be one of the domains, should not be in the domain of the function. So 3x minus 1, if you equate it to 0, you get x is equal to 1 divided by 3. 1 divided by 3. So it means that this function, or this rational function, will have all values of x from -infinity to +infinity, but the values we don't want is the value 1/3. So -infinity to 1/3, and from 1/3 to +infinity. All other values, we are okay. Then the function will continue to exist. So there's a domain of the function. Then the third example is when you have a function and the function is under the square root sign. It's under the square root sign. Then what do you do? Okay. So since the square roots you cannot find square root of a negative number, so we also will have to equate the function under the square root sign to 0 and make sure that x will not take that value. So 7x plus 5 should always be greater than 0. It means that 7x should be greater than -5, x should be greater than -5 or 7. So the domain of this function should satisfy all x that are greater than -5/7. Okay. So that the domain can be expressed as an interval. So -5/7. We can't take negative value from -5/7 all the way to positive infinity. If you have values of x in that range, this function will be defined. Okay. Before I get onto the graph, I want to show you the summary of what we've done in the text file here. Okay, so this is one of the model books that was developed by one of the lecturers, and they have defined functions, or they have also given exactly what I'm showing in the PowerPoint. So here, like I said, a function consists of a set of inputs and set outputs, and the rule for assigning each of them is what we saw in the PowerPoint. So if you have y is equal to f of x, then y is the output, and the name of the function is f, and x is the input. Some of their diagrams are a bit faint. Last semester, we saw the types of one-to-one, many-to-one, and on and on. Now, what we were discussing in the PowerPoint was the domain, the range, and the codomain. So this is a graphical form. Now, so the domain will be the x inputs, and then the range will be the y outputs. Basically, that is that they are using the graph to find the domain and the codomain. So when you pick the domain, you substitute into the function, and the function will give you the range. Actually, what I'm looking for is the definitions here. Here, this is what I'm looking for. These are the three rules we just went through in the PowerPoint. So rules for finding the domain of a function is number one. If the function happens to be linear or quadratic or cubic, then the domain will be all real numbers. So any linear equation, any quadratic equation, any cubic equation, then your domain will be all the values of x that are real numbers. Then the second type of function we saw in the PowerPoint was when you are finding the square root of a function. Now here, the domain is making sure that x is greater than 0. That was the last example that we saw. Then the second example we saw in the PowerPoint is that when you have a rational function, you have a numerator and a denominator, then you equate the denominator to 0. Okay, so this is to paraphrase what we've seen in the PowerPoint. And to be able to determine the domain of those functions. So there are examples here. We've seen an example here as well. X minus 2, you equate x minus 2 to 0, means that x should be greater than 2. Then you can write it in the form of an interval. So it must be from the value 2 all the way to infinity. Then when we had rational function, then we equate the denominator to 0 and make sure that the value of that x should not be in the domain. So x should not be equal to -2. Again, then you have all this. So I'm just reiterating what we saw in the PowerPoint, also in the lecture material. Let's go on. Let's now look at the graph of a function. So functions can be plotted in the form of a graph. The graph of a function is a set of all points of x and y that satisfy the domain and then the range. So we have something like this. So given y is equal to f of x, when you substitute 1, you will get f equals to 2. So the point 1, point 2 will be a line on the graph. Now, sometimes you may be asked to test the graph. The graph of a function can be crossed at most once by any vertical line. So when you place vertical lines on the graph, it can be able to tell the various points in the graph, and then they can also give you the values of the functions in those places. Okay, so vertical test is the graph of a function that can be crossed at most once by a vertical line. On and on and on and on. it is crossed more than once, then you will seem to be having an issue. Okay, so what they are trying to say is that if you draw a vertical line through a graph and it gives you more than 1 point, for example, the graph on the right, this one, this 1, 2, 3, 4, the fourth vertical line is crossing the graph at the top here, and it's crossing the graph in the middle here, and it's crossing the graph at the bottom here. So when you have something like this is actually a graph, but it is not a function because of the definition of a function. Please, I hope you understand. A function says you take an x input. The x input are the values on the x. So if you pick a value of x and it hits the graph, it should give you a value of y that doesn't pick any other value. The line shouldn't cross the graph more than once. If it crosses the graph more than once, then it is a graph, all right, but it is not a function. We have what we call, is it one to many? Yes, one value, it will give you many points on the y. That is not a function. So we can use the vertical line to test whether a function is a function or it is not. Okay, what else do we have here? So these are the properties of, or some examples of a function. 2x plus 5, we are plotting that from x less than minus 2. So x than minus 2 is starting from here and it goes there. Okay, so you can pick various values of x and you get a line going down. And then minus x plus 7, we want to plot it from x greater than minus 2. So that gives us the line like this. Okay, so this is an example of a graph. And if you try the vertical line, you see that it will cut the graph once. Now, what do we do with functions um, uh, if they are functions? Then you can add them, you can subtract them, you can multiply them, you can divide them. These are properties of a function. Okay, so domain of f intersected with the domain of G. Okay, so you can add them, you can multiply them, you can subtract them and divide them. So this is an example. Given f of x is 3x minus 1 and g of x as x squared minus 2x minus 3. Okay, so when you ask to add these two functions, algebraically, you add them and then arrange them in the form of descending powers of x. So 3x from minus 2x will give us positive x. X squared will remain on this one. Minus 1 minus 3 will give you minus 4. So that gives you x squared plus x minus 4. And if you ask to subtract them, then again, you do the same thing. Like terms, you group like terms, and then you summarize your results. So 3x minus 2x will give you 5x. Minus 1, so minus 1 minus 3 will give you positive 2. And then minus x squared will give you negative x squared. So this function reduces to minus negative x squared plus 5x plus 2. And that gives you the difference of the function. And then the product of the function too, you must multiply them one by one. So this example helps us to know that we can add them, we can subtract them, we can multiply them. Now to divide them, then you get a rational function like this and equate the denominator to 0 and make sure that that function doesn't go to 0. Okay, now then what else can we do with these functions? You can find the composition of them, f naught of g, g naught of f. I think we saw some of these things last semester. So I hope we can take our time and do these things. Types of functions. We have polynomial functions. That is from linear to quadratic to cubic, on and on and on, where the functions have powers from power 0 to power 1 to power 2, on and on. And then we have functions that are in the form of ratios. So polynomials that are divided gives you what we call rational functions. Then we have power functions. Okay, now power functions are the functions that are raised to a certain power. Some becomes exponential, some becomes rational, raised to power, on and on and on. Now, in the slide, there are some examples here. So I'm going to jump these examples. These are applications of using functions in the form of a story problem. And this example 2, and then this example 3 example. Now, let's see how to apply this in calculus because that is our aim. Now, so there are two main areas of focus when we are applying functions in calculus. One, when you want to find the line that is touching the curve, we call it the tangent of the function. So if I draw a line that touches the function or the curve at a point, it becomes the tangent of that particular function. And how to find that tangent line is our interest. So one, we will have to find a way of determining this tangent. Then number two, finding the area of a region bounded by a curve. So again, let's say that I have a curve like this, and we want to find the area of this curve. So these are two applications to how to use calculus, or what we are interested in when we have functions, either in a graphical form or in the form of an equation. Another application is we are able to represent functions in the form of velocity, distance divided by time. That gives you velocity. So when you're given a problem, we can be able to write an equation involving the distance and then the velocity. We have what we call the instantaneous average, that is distance covered over elapsed time, that approaches zero. When I see a police officer, my instantaneous velocity was 60 miles per hour, or you can convert it kilometers per hour. So these are some applications of these functions. So you end up getting sometimes quadratic equations that you can solve, or you end up getting linear equations that you can solve. Just want you to see some applications in here. Okay, any other? Then we end with limits. Okay, so remember that last semester, we were able to look at limits of a function, and our interest was to evaluate the limits. So when you are given the function and you are asked to find the limit, we must test. We have certain rules that we need to test. So first of all, the limit of a function, like we saw last semester, is as x approaches a particular value, the limit must be equal to, the limit must be a value. You must evaluate it and it gives you a value. If you can make the value f of x arbitrary close to L by taking x sufficiently close to A, that's the interpretation of this. Okay, so all we are saying is that when you have a function and they ask you to find a limit, you substitute the value of the limit into the function and you can get the corresponding value of L. An example is this. Let's a limit of f of x as x approaches minus 2. This is the function has been drawn, minus 3x. Now, if you substitute x equal to minus 2 into the equation negative 3x, you end up getting x equal to positive 6. So at that point, that will be the limit of the equation for negative 3x. You substitute minus 2 into the equation. That's the first example we have here. So note minus 2 for the second one cannot be used because that gives you a constant value. Then the properties of limits. Again, this was in some of the slides we saw last semester. You can multiply limits, you can have a constant multiplying them, you can add them, you can subtract them, you can divide them. Okay, so I think this should be a summary of the things that we saw last semester. The limits, when you are dividing them and you divide them, I think you got a question like this in the exam. When you substitute and it gives you indeterminate, then you may have to do the L'Hopital rule, or you may have to simplify further. then you can get the limit. I hope you remember all this. Limit to infinity. We saw that too last semester. One-sided limit. That is, if you make f of x arbitrary close to m, what is the value of x? So we can have one-sided limits. You can have limits and the continuity of a limit. That's a function, is a function defined at a particular point. Then the properties of these limits is that when a limit is continuous, you may have a value or you have a discontinuous value at that point. Because we've gone through this in the first semester, that's why I'm glossing over them. Okay, so properties of functions are, like I said, you can add them, you can multiply them, you can divide them if the functions are continuous. A polynomial function is continuous everywhere. A rational function is continuous only at the domain of the function. When the domain of the denominator goes to 0, it is not defined. Then intermediate IVT, intermediate value theorem. Okay. So here, if you have a function within a closed interval, and L is any number between f of A and f of B. This is A, this is B. So the intermediate interval means that we are going to find a value in between the 2 points, f of A and f of B. Then there is at least one value within the interval A and B such that f of C will give you L. This is a theorem. We call this intermediate value theorem. Okay. I'm sure we'll see examples like that. So given f of x is equal to 3x squared minus 2x plus 5, show that f of x is equal to 0, and then has at a least value solution between 1 and 2. So when we substitute f of 1, we have minus 4, which is less than 0. And if I substitute f of 2, we have the value 3, which is greater than 0. Okay? So f of x is continuous for all values of x, since for the point 1, it is less than 0, and the point 2 is greater than 0. So by the intermediate value theorem, there should be a value between this so that f of c is equal to 0. I think what the point of this theorem is that when you are given a function and they're asking you to use the intermediate value theorem, you substitute the values into the function, and from that you evaluate whether there will be an interval between the 2 points that another value can exist. So from the result of minus 4 and then positive 3, obviously there will be a value in between minus 4 and 3. So that means that we will have an intermediate value in between them. Because minus 4 to positive 3, at least the value 0 will be there. See whether there is anything more I need to. These are applications to these functions to differentiate them. But we'll look at differentiation next week, so we can leave this part. Okay, so basically, this is what function is. Our aim for today is to revise what is the domain of the function, what is the range, and how to be able to find the limits of the functions and show its applications. Okay, so is there any question or is there any comments? Now that we look at the exercises which will make us revise what we've looked at so far. So we've gone through the definition of a function and components. We've gone through a domain and a range of these components, and we've been able to look at how to evaluate limits algebraically. So what we are left with is looking at some worksheets to be able to complement all that we've looked at. So I'm going to show you the worksheets. Like I said, I'm still developing the terms or the things on the elements. So let's see whether. Okay, so this is the Moodle platform. And yesterday when I checked, I realized that you were all here, you were all here. But some of you have not been here yet. Okay, so this is the page. I have placed the course outline. This is a course outline. And then what we are going through today, I have not placed a PowerPoint because I need to add a few things to it in here. So I will do that later. But the worksheets that I'm talking about, they are here. So I'm just going to go through a few of them, show you what you need to do. And then I will, where are they? Okay. Don't be here. Okay, so these are the worksheets. Basically, the aim is to help you practice what we've gone through and then to be able to revise some of the things that we have gone through today. So in here, the first worksheet, we have functions, various functions. This is a linear equation. This is a rational equation. This is a quadratic equation. And remember what we saw in the PowerPoint and as well in the model document, that if the function is linear or is quadratic, then their domain are all real numbers. But if it is a rational function, then you equate the denominator to 0. So the first part is evaluating the various domain values. So what is f of 3? What is f of g of 4? What is h of 2? On and on and on. Okay, so question 1 is evaluating and finding the range of the various inputs here. That's question 1. And then question 2, yeah, the same. This time the function is we have natural log of a function, we have sine of a function, we have exponential function. Again, you still want to find the range of this input of x. Obviously, some of the equation, some of the outputs will be decimals, and therefore, please leave them in 3 significant figures. Then question 3, yeah. Again, please, I know there's a lot, but just make sure you can do as many as you can. It's a worksheet and it's a trial worksheet, so do as many as you can. So how do you sketch each of the function? Linear equations, like we learned last time, is like x-intercept, y-intercept, then you draw. So this is linear, this quadratic, this is also quadratic, this is quadratic. This is polynomial. These are all, if you know the x-intercepts. So when x is there, what is y? When y is there, what is x? And then for quadratic, they've given you the interval. By the way, last semester, I showed you, I think I showed you a site where you can learn how to plot this. So this is f of x from 2x plus 1. So you can use that site also to be able to help this. I'm talking about this. So if you come here, you can say that let y be equal to 2x plus 1. So if you're interested in, remember that this particular demo or this particular plot is plotting from infinity to infinity. So if you are interested in certain interval, then you will give the interval that is needed. So this was 2x plus 1. The other equation was 5x. Maybe let's make f of x equal to x squared. Of x equals to x squared. So f of x means that y is equal to x squared. You know that would be a parabolic function, and that gives you that. So you can use this plot to be able to check the plot of some of these functions and see how they behave. On and on and on. Number 4.2, you are plotting the function, and by this time you must take the range. So when you plot from the graph, you can find the range of the values. X squared plus 2x minus 8, 1 over x. This is cos of x, this is tan of x. And then number 5, find the domain of each of the functions. Still domain here. Evaluating this. They've given you range here. So you must find, they've given you the range and they want you to find a domain. And then, given this f of x, g of x, and h of x, they want, again, to evaluate these functions. When is f of x equal to h of x? When you add f of x to g of x, what is the value of f of equals to 0? It means solve the equation. Okay, so this particular worksheet is to help you practice the various determination of domain and the various determination of ranges and how to be able to evaluate the domain and the ranges of all these functions. Now that's the first worksheet. The second one is also based on domain and range. So write down the domain of f of x equal to 3. That is y is equal to 3. Obviously, that will be, this is a constant function. So, and f of x equal to x, that would be a linear equation. F of x equal to x squared, that would be quadratic. And then when you have absolute values, in the PowerPoint, it tells you how to find the absolute values of these functions. So you can use that. When you have a square root, remember what we learned about square roots. When you have a rational function. Okay, so these questions, again, is going to test you on all the properties we gave you. Then when you have functions that are in two parts, one is quadratic, one is rational, how will this function look like? And then how do you find the domain of them? Let's see what you can do. The ones you will have challenges with, we'll leave them for more interactive sessions when subsequently. Now, the last one is on limits. Okay, so again, to revise what we learned last semester, what's the limit as x approaches 0? What's the limit as x approaches minus 2? On and on and on. This one is a lot. So I think we should, if you take maybe the first 10 questions, you're able to do them. Or if you can do more, fine. But please, I'm not expecting you to do all of them. So help us to be able to build our capabilities as we go on. So any questions, any comments? Today is our first class. I've gone through a lot. If I'm teaching this physically, each example would take more than 5 minutes. So looks like I'm online, so I've gone very fast. But if you have time and we practice all this, that will take us quite some time. But all these tutorial questions is to help us to make sure that we really understand the domain, the range, and how to find the limits of a function. Any questions or any comment? Yeah, there are no questions. Kingsley, you don't have any questions or any comment? You okay?
Yes, sir. Yes, sir.
Okay.
So
Okay,
I think we have to revise on the assignment that you've given us. We have to work on it for
yes,
it to sharpen us to prepare us for the coming topics.
exactly so. I know, like we experienced last semester, almost all of you are working. So we'll take it gradual as we go on, and let's see how best we can be able to do as many questions as possible. If you saw the exams you wrote, you could tell that if you are having time to practice, you should be able to get your questions. So let's go through this semester the same, so that by the time we are midway through, everybody should feel comfortable and know how to handle their questions when they come across them. Yeah. Okay, so we'll end on this. Hopefully next week, I'm sure by then you would have tried some of these examples and questions, and then give me a feedback as to whether we need to do more or go over some of these things. The topics are a lot, and the weeks are not too many, so every one of us will try to do what we can to make sure you cover the topics. You need to be familiar with the topics, so that you can apply them in your field, in the other courses you are doing. But so far as examination is concerned, hopefully when we are getting there, we'll prep you up to prepare you for what you need to write exams. So please, I hope you will not be stressed enough too much, or worry. It's not the word stress. I think to worry too much about how will we fare in this course. But basically, let's take a day at a time to be able to equip ourselves. Okay. So thank you for coming. God willing, next week we'll continue with the topic. Hopefully, I should populate the LMS with the PowerPoint when I'm done. Yeah. So enjoy the rest of your lectures today. Bye.
Thank you very much, sir. We really appreciate it.
Thank you too.
We'll work on it.
Okay then. Okay. Bye.
Bye, sir. Bye, sir.
Excuse me. Excuse me.
Yeah.
Sorry, the next class we went.
Is it?
The next class we went.
It'll be 9.
Sorry, now they can't go. Now they can't left. Now they can't left. I go underground that.
Oh, he forced.